Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've now seen R-square and adjusted R-square separately, but the real insight comes when we look at them together, and that's why we say that theta and R usually have these two elements always together. What you might notice when working with data and running regressions, you might see that the R-square goes up, but the adjusted R-squared actually goes down. So the question that we're going to try and answer through this video is, what is that disagreement trying to tell us about the model that we're building? And in order to do that, let's do a very quick recap. What is the R squared telling us? Remember, the R squared is the fraction of variation in Y explained by the model. And mechanically, we said that when you add regressors, R squared can only stay the same or increase. Keep in mind, this is not a flaw. It's just how least squares work. And adjusted R squared was trying to do something different. So it was asking a stricter question, is did the new variable improve the model enough to justify using up degrees of freedom? Okay. So unlike the R square, the adjusted R square can actually increase or decrease. And that difference is very informative. Imagine that we start with a model that it's simply y equals to some beta null plus beta 1 x1 plus an error term mu. Now you add, let's say, a completely irrelevant variable. So that is just pure noise. It means like your model next would be beta 0 plus beta 1 x1, let's say, plus beta 2 w plus u. And this w is like the completely irrelevant variable. In those kind of cases, what you should expect to happen, so let's say that the R squared out of this first model was 0.2, then if you run this new model, you will notice that the R squared will be actually bigger than the or equal to the 0.2 that you had. In any case, you'll see that it will go up a little bit. However, the adjusted R squared of this particular case is very likely going to go down by a little bit. Because the R square will say, you explain slightly more with this new variable in here, but the adjusted R square will say, no, that's not enough to be worth it to be included in this model. When R square and adjusted R square move in opposite direction, what the model is telling you is that, so let me write that, if moving in opposite directions, they are telling you that these additional variables are not helping much, at least not jointly. And I'm going to highlight a word here because it's very important. That word is jointly. So in a sense, adjusted R square is quietly asking, do these variables taken together improve the model enough? So updated question now is, do these variables together improve the model enough to justify it all over again into using degrees of freedom? Now keep in mind, this question is no longer about one coefficient or one t-test. This question is about a group of variables. which is why I highlighted this jointly in here. So if you are tempted in a regression to just look at the t-statistics of your separate variables, keep in mind this can be misleading because variables can be insignificant individually. However, they can be important together. And this is where model level thinking begins. Once you start asking whether variables matter together, it means you've moved beyond individual coefficients and into what we will call joint hypothesis testing. Adjusted R-square hints exactly at this problem, but keep in mind, it does not formally test it because the job for that is the job of the F-test. So I'm just gonna highlight it here. So adjusted R-square hints at it, but it's the F-test that formally tests it. So overall, remember that when R-squared increases but adjusted R-square falls, the added variables didn't improve the model enough jointly. In the next video, we'll introduce the F-test conceptually and see then how it formally tests it, and answer the question, do these variables matter together or not? So stay tuned, and I'll see you in the next video.